exactly 11:40 at night and today is Halloween. I'm super excited because I love Halloween. Here's all the candle because I love candles and well, I love Halloween and this is pumpkin, so it's a perfect combo.
It's a perfect combo.
In 1900, a new door was opened in the world of physics. A physicist, after years of devoting himself to the field of science, finally revealed his theory on December 14th. That year, he was 42. Who was this person, and how did he change the way we view the world nowadays? It's Claire Mass, everything physics, everything chemistry. I've got you covered. Hey guys, welcome back to my channel, or should I say welcome, because this is my first video. My name is Claire, I'm currently 11th grader, and on this channel, Claire Mass, you're gonna learn everything about physics, chemistry, from a high school student's perspective, and some live updates, studying tips, and more. So if you like this video, please subscribe, and I can't wait to make more memories with you. That's guys. The person we're talking about is Max Planck. Max Planck. You might have heard him opening the door of modern physics and basically introducing the formula that we all know about. E equals to h mu. He talks about quantum physics, which is one of the two branches of modern physics. So Max Planck was born in 1858, approximately 200 years ago, in Kiel, Germany. You can guess what his father, his grandfather, and his father all did. They were professors. It makes sense, right? You can actually explain, like, if your father, your mother, your grandfather, your grandmother, they're all doctors, there's like 90% chance you're gonna be a doctor. When you come from non-life teachers, there's like a 9% chance that you're gonna be a teacher too, because you're like, I want to be like mom, I want to be like dad, they are teachers, now I want to be a teacher. So maybe young Planck has heard everything about physics and just decided to continue his family's legacy. In 1867, his family moved to Munich, which we all know, a city full of music, culture, and nature. So maybe young Planck had a really cool and amazing life there. So during the weekends, their family, they go mountain hiking, trail hiking, well, just like a normal family. So during his college years at the age of 21, well, while normal people are like fighting for their grades and studying, completing their masters, he submitted
A thesis on the second law of thermodynamics,
which you can think of it as you writing about your favorite things. Well, basically
that's a superpower. That is his philosophy. That's his fundamental.
he thinks that this is unbreakable. It's like the absolute law of nature. So, what is the second law of thermodynamics? It talks about energy in a kind of state of entropy of the entire universe that will increase over time. Well, then you might have guessed. He became a professor. When he spent his time in Berlin from 1885 to 1927, he became interested in hot objects and how they emit energy based on their wavelengths. We're going to talk about this because at that time, many scientists have tried to use certain ways to explain the things they see, but they cannot explain the situation. Well, we're going to talk about why, because this has something to do with the fundamental and how classical physics is built. So, what's the difference between modern physics and classical physics? Because as far as I know, they're all physics, we all have to learn them, we all have to memorize them, we all have to be tested on them. So what exactly is the difference? Classical physics is built on our best friend, Isaac Newton's publication, Principia. You know, the one that got hit by an apple and came up with a lot of formulas that we have to memorize, that one.
Our best friend.
Including, you know, like the first law of Newton, inertia frames, the second law of F equals to ma, the third law of reaction pairs. Classical physics include optics, acoustic, electromagnetics, and classical mechanics. The scientists that try to explain this, they all use classical physics. It seems reasonable when we're talking about big stuff. Like you were talking about F equals to ma, you're talking about things from a broad matter. It's like 5 kilograms. I use the force of 5 Newton How much is their acceleration? You're viewing from big stuff. You're talking about big stuff. Hot object emit light. It's atomic level. It's small. It's very small. So when you're talking about this stuff, small stuff, using
big stuff,
you're gonna lost it. Cause you're gonna be like, it won't fit. So that's where modern physics comes in. Modern physics can be broken down into two branches, which is the one we're talking about today, quantum, and the other one, relativity. By Einstein, modern physics is still a continuous action. So basically, you see researchers doing research about it, trying to find more things about quantum. So this form of physics can talk about things that is past Newton, which is like understanding energy at like a particle matter. So you might have heard of the infamous E equals to mc squared. It's talking about energy at particle matter. So what would happen if we use classical physics like the old scientists to explain light emissions of objects? This is what light emission is supposed to look like, but when looking at it from a classical angle, it turns into something like this. At an ultraviolet range, you can see the object seems to emit an unbound quantity of energy. This is ultraviolet catastrophe, also known as Rayleigh-Jeans catastrophe. When viewed from a modern angle, however, the problem is solved. By Planck. Look at this pic. They use photons to explain this graph. What is a photon? Well, photon is defined by Einstein. It is like tiny particles, like electrons, but in a light form. Modern physics discovered that light is actually made out of particles but can also perform wave-like activities, which we'll elaborate in later videos. So at that time, Planck used the word packets or quantum to explain energy in particles. So by explaining it like this, or quantization, we now know that the photons, or the little packets, or the quantums, are each emitted at a certain energy level and wavelength, unlike the continuous waves used in classical physics. So let's take a time machine to October 1900s, when Planck announced his Planck's radiation formula, combining the ones of Wien and Rayleigh's, which shows the relation between energy of photon and the frequency of the radiation, which we can use mu or f. The h stands for Planck's constant, which equals to 6.626 times 10 to the power of negative 34 joules per second, or 4.136 times 10 to the power of negative 15 electron volts per second. In 2 months' time, introduce a quad of energy in small packets called quantum that hold a certain amount of energy. In December of that same year, he presented the explanation at a meeting in Berlin, rejecting his belief of the second law of thermodynamics, which is classical physics, and we're talking about modern physics here, hello? So, you might think, well, it's happily ever after. The princess and the prince, they live happily ever after. They kiss, they get married, etc., etc. But the story does not stop there, because this is life, people. This is life. Life is not perfect. So, do you think people actually believe in him? Because this, what Planck did, is a thinking game, a brain game, a thing that is in his brain. So people, they want proof. Where's that proof, they may ask. So it wasn't until 10 years later when another person, Boyer, which is the one that discovered the Boyer model, he used mathematics to calculate positions of special lines based on Planck's theory, and he proved them correct. So Planck received a Nobel Prize. So we all know Planck through physics books, maybe, after I've talked this much, my video, then you might think, oh, what does it have to do with me? Because
Planck is Planck. I am me. I am myself. I'm my own person. What does it have to do with me? Modern physics is just modern. It has modern in it. Doesn't mean I'm going to use it.
well, it actually does a little bit because, we can know more about the universe. So, thanks to Planck, we can now use this data to know a little bit more about the formation of galaxies and clusters. So, the European Space Agency, they actually formed the Planck mission, which specializes in the analysis of the cosmic microwave background radiation remnant glow of the Big Bang. Well, I know you're all thinking about the Big Bang Theory. Sheldon, young Sheldon. Well, I know that. I love that, but we're not talking about that. So, Big Bang is actually a theory that describes how the universe is formed. You know that the universe is once like a popcorn, like a corn in a can. It's super hot, super packed, and expanded, and exploded just like a popcorn at home. So, by analyzing this kind of radiation, while it expanded and exploded, we can know a little more about the early universe, the contents of its origin, and it can give us a little more information about moments after the Big Bang. So, you might have heard how the universe is still expanding until it can't expand anymore. This is based on this theory. Planck has made a huge impact and revolutionized our understanding of physics. Thanks to him, we can now understand how light emission works. That's it for today, and I hope you guys all like this video. See you next time. Bye.